All right, this is going to be the screencast for the post lab for lab 2 changes in potential that we did basically as a demonstration lab in class. Now, highlight all the energy forms you observe throughout this lab. Think this through. There is elastic. Whoops, I kind of gave that one away. There is expansion of the balloon as it gets blown up. Think about how there is going to be friction between the straw and the string. Keep in mind that there is going to be this force pressing down on the whole system, not just on the balloon and the string and the straw, but also the chairs and you, etc. That'll be part of this. Think about how the balloon moves and what powers it as it does that. And then also think about what you might hear as this balloon shoots along this distance. So those things should help you come up with at least the main forms of energy. Now, you have already got the data here for the distance and for the time. You'll need to calculate the speed, and then you will have this data of the mass of the balloon straw system, and you'll need to calculate kinetic energy. So let me show you first how to do average speed. There's a basic equation for speed, which we'll talk about the difference between velocity and speed, but for this lab, let's just call it velocity and not speed that we're looking for. So velocity is equal to the distance that something travels divided by the time it takes that object to move that distance. Think about miles per hour, right? That's a speed, and if it goes in a straight line, a velocity, and it's in miles or distances per hour time. But we're dealing with a different distance. We're dealing with distance in meters and time in seconds. But all we need to do is take this equation and plug the numbers into it and see what we get. Now, this is for example purposes, so your data may be different. Just make sure you use your data, not mine. So the distance, we're going to say that this balloon traveled is 10 meters, and we're going to say that it took it 2.5 or 2.5 seconds to travel that distance. When you divide that out, right, you get 4 meters per second. Now, this is important. When you divide, the meters does not cancel, neither does the second. So this is considered 4 meters per second, which is a velocity. And that's how you calculate velocity. Now we need to clear this, and we will now go and let's calculate kinetic energy. Kinetic energy is a little trickier, and it's 1/2 mass times velocity squared. Let's not worry so much about the units. We'll discuss that, and you'll become more familiar with that later. Let's think mainly about the math. Well, first off, we know the mass of the balloon system. We measured it. And let's say that its mass was 100 grams, right? You just need to convert that first into kilograms and tell me how many kilograms this is. Remember that the way you do that is you divide by 1,000, or you move the decimal place 3 places to the left. So in this example, let's say that it weighed 0.1 kilograms. Because I just converted 100 grams, 1, 2, 3, I get 0.1 kilograms. So that's my mass. Our velocity, right? So here's our mass. Our velocity we calculated just a second ago, and we got 4 meters per second. So now that we have all this data, we're ready to plug it into our equation. So we'll do that. First thing you do is you take 1/2 times the mass, which is 0.1 kilograms. And then you multiply that by the velocity squared. Well, the velocity is 4 meters per second, and we need to square all of this. Now, you square both the number and the unit, and that'll make a lot more sense later when we start talking about what a kilogram times a meter squared per second squared is, but it's actually a joule. But that'll help you in identifying units. So we now do the order of operations. We square something first. So 4 times 4 is 16. And meter times a meter is meter squared. Divided by a second times a second is second squared. So see how I didn't just square the number, I also squared the units. Now I'm going to multiply this, the order of operations in multiplication. It doesn't matter how I do this, right? So I can go in any order, but let's say I do it this way. I get my calculator out and I take 0.5 or 1/2 times 0.1 times 16, and that's going to bring it out to 0.8. It's going to be a crazy unit though. It's going to be kilograms times meters squared per second squared. That's a lot to remember. So what scientists say is, let's call that, instead of calling it 0.8, we're going to call that a joule. And this is your answer. That's the kinetic energy, right, of this balloon. And joules is the SI unit for energy. Just to give you an idea, if you had about 1,000 joules, it would run a fluorescent light bulb for about a little over a minute. So a joule is not very much energy. Let's move back to our lab now, because we've got this filled out and this filled out. And it says, if we assume no energy loss through the transformation of elastic potential energy to kinetic energy, how much elastic potential energy was stored in the stretched balloon, in the stretched rubber of the balloon, and then explain it? Well, this is going to be a good chance to think about the law of conservation of energy. All right. And I'll type that out for you. The law of conservation of energy. And what that says is that energy is not created or destroyed. It's just transferred from one form to another. So I am going to tell you that all of the potential energy in that system was converted into kinetic energy. And if that's the case, you can figure out how much potential energy, right, is there by going in and looking at how much kinetic energy you calculated. Because all of this kinetic energy came from somewhere. And where did it come from? It came from the potential energy. So you need to write that up, mention the law of conservation of energy and how it's going to change forms and does not get destroyed. Next, identify factors that influence the potential energy and kinetic energy in your investigation and explain using the data you collected. Now, what are some things that could affect how much kinetic energy this balloon system had? That's a tough one. Think about it. I'm going to give you one as an example, and I want you to come up with a couple others. How much you blew up the balloon, right? Wouldn't that change how much potential energy is stored in this balloon? Therefore, how much is going to get converted into kinetic energy? And now think about some other things that are going to affect the system that way. And you'll write those. I need you to come up with 3 here, all right? So you need 3. And then finally down here, this you're going to do on another sheet of paper. You're going to fill out an experimental design diagram with one of these factors that you identify, and you are going to make it your independent variable because it's what you decide to change. So for my example that I just gave you, if I did an experiment inflating the balloon to 50%, then 70%, then 90%, I would then be able to do an experiment, right, to determine how much the expansion of the balloon affected the overall kinetic energy